So let us look at this very interesting question. So in this question, you're given that x minus iy, the complex number, is equal to the square root of a minus ib by c minus id. So if this is so, you're asked to find the value of x square plus y square whole square in terms of a, b, c, d. This is a question based on the properties of modulus. So how do we proceed? So you want some information about x square plus y square. And you know that x square plus y square is somewhat related to the modulus of this complex number. So first what we do is, let us square this equation on both sides. So x minus iy whole square will be equal to a minus ib by c minus id. Now let us apply mod on both sides of this equation. So mod of x minus iy whole square is equal to mod of a minus ib by c minus id. So this implies, so actually the square has to be inside this mod, but we have a property which says that modulus of z square is equal to mod z whole square. Modulus of z power n is equal to mod z power n. So this square can go out. So what is mod of x minus iy? This is nothing but root of x square plus y square. This is mod of x minus iy whole square is equal to modulus of z1 by z2 can be written as modulus of z1 by modulus of z2, mod of a minus ib by mod of c minus id. That is equal to, what is the mod of this? Root of a square plus b square divided by root of c square plus d square. So this implies root of x square plus y square whole square is x square plus y square is equal to root of a square plus b square by c square plus d square. You would be guessing where I'm trying to go. Now I'll square this equation again on both sides, which gives me x square plus y square whole square is equal to a square plus b square by c square plus d square. So this will be the answer to this question. Thank you.